Welcome to this expert-level training module on Microsoft Foundry. Today, we will master the critical foundational skill of creating highly effective system and user prompts for generative AI models. Welcome to this expert-level training module on implementing generative AI applications and agents using Microsoft Foundry. Today, we are focusing on one of the most critical foundational skills for any modern AI engineer: creating effective system and user prompts for generative artificial intelligence models. At its most fundamental level, a prompt is simply the natural language input you provide to a large language model, or LLM, in order to elicit a generated response. This generated response is technically referred to as a completion. But to truly master prompt engineering, we must first understand exactly how these generative AI models work under the hood. The ability to generate content is based on a language model that has been exhaustively trained with massive volumes of data, typically sourced from the public internet and other comprehensive document repositories. These generative AI models deeply encapsulate the complex semantic relationships between language elements. In technical terms, the model mathematically maps how specific words and phrases relate to one another within varying contexts. When you interact with a generative AI model through a prompt, the model leverages those learned mathematical relationships to initiate the generation of a meaningful, highly relevant sequence of text. It functions much like an incredibly advanced, immensely scaled-up version of the predictive text feature on a smartphone, analyzing the sequence of text you provided in your prompt and calculating the absolute most probable continuation. Your prompt acts as the absolute starting point for this probabilistic prediction engine. If your starting prompt is highly detailed and structurally sound, the resulting text prediction will be highly relevant and professionally formatted. Conversely, if your prompt is vague or lacks necessary constraints, the model's output will likely degrade in quality. Throughout this comprehensive session, we will break down the specific types of prompts, how to systematically format them for optimal results, and exactly how to implement them within your Microsoft Foundry projects to build powerful, enterprise-grade AI solutions. While there is no specific code required to understand the conceptual definition of a prompt, it is vital to recognize that your entire application architecture will revolve around securely transporting string data from a user interface directly into the AI model's backend processing engine. As we dive deeper into prompt architecture, it is absolutely essential to understand that not all prompts serve the exact same purpose. In enterprise AI development, there are two primary types of prompts that you must orchestrate: system prompts and user prompts. A system prompt is an overarching instruction set that explicitly defines the behavior, professional tone, and strict operational constraints of the generative AI model. You can think of the system prompt as the foundational job description, or the baseline reality for your AI assistant. For example, a system prompt might declare, "You are a highly helpful step-by-step mathematical tutor. You must respond in a cheerful, friendly manner. You must always cite your sources, and you must explicitly decline to provide any medical advice." This system instruction runs invisibly in the background, aggressively governing how the model handles all subsequent inputs. Conversely, a user prompt is the specific, functional input designed to elicit a direct response to a question or instruction. This is the text actually typed by the human user interacting with your application. For instance, a user prompt might say, "Summarize the key considerations for adopting generative AI described in the attached document for a corporate executive. Format the summary as no more than 6 bullet points with a professional tone." In a robust Microsoft Foundry application, the system prompt is typically hard-coded by the development team to ensure strict behavioral guardrails are permanently enforced, while the user prompts are dynamically generated by the end users in real time. The generative AI model is mathematically trained to respond to the dynamic user prompts, while simultaneously obeying the overall, unshakable guidance established in the system prompt. Mastering this dual prompt architecture is the absolute key to building safe, predictable, and highly effective enterprise AI agents. When architecting an AI solution, you must segregate your prompts logically. System instructions are stored securely as configuration variables within your backend environment, whereas user prompts flow dynamically through your web application's input fields, ensuring end users cannot easily overwrite your application's core safety guardrails. This diagram clearly illustrates the dual prompt architecture. Knowing the difference between system and user prompts is only the first step. You must also master the art of crafting them effectively. The quality of the responses you receive from generative AI assistants depends heavily on the specific linguistic structure of the prompts you submit. Microsoft provides 4 highly effective tips for optimizing your prompts. First, you must be exceptionally clear and specific. Prompts with explicit, unambiguous instructions will always outperform vague language. Do not just ask the model to write a report. Tell it exactly what the report is about and who the intended audience is. Second, you must actively add context. Context anchors the model's probabilistic engine. You should explicitly mention the broader topic, the specific target audience, or the exact format you desire. Third, you should utilize examples within your prompt. If you want the model to output data in a very specific, nuanced style, provide a concrete example of what you mean directly in the prompt text. In data science, this technique is commonly referred to as few-shot learning, where demonstrating the desired outcome is vastly more effective than simply describing it. Fourth, you must explicitly ask for structure. If you need the data organized, tell the model to format the output as a markdown table, a numbered list, or concise bullet points. For example, a poorly designed prompt would be, "Tell me about AI adoption." A highly effective, optimized prompt would be, "Summarize the key considerations for adopting generative AI for a corporate executive audience." Format the summary as no more than 6 bullet points with a highly professional tone, and include one example of a privacy risk. By strictly adhering to these 4 foundational prompt engineering guidelines, clarity, context, examples, and structure, you will drastically improve the reliability, accuracy, and overall quality of the completions generated by your AI models. Implementing these best practices programmatically often involves utilizing prompt templates. Developers write robust string templates with placeholders for dynamic data, ensuring that every time a user submits a query, the backend code automatically wraps it in the mandatory context, formatting rules, and few-shot examples required for optimal inference. Observe the prompt optimization workflow. We take a raw idea and apply best practices, adding clarity, injecting context, providing examples, and requesting structure. Our fourth crucial concept involves the management of conversation history and contextual memory. When users interact with a generative AI application, they naturally expect the system to remember what was said earlier in the conversation, much like a human being would. However, the underlying application programming interfaces, or APIs, that power these language models are inherently stateless. This means that every single HTTP request sent to the model is treated as a completely isolated, independent event. The model natively retains absolutely zero memory of your previous prompts. To successfully keep a conversation consistent and relevant, your generative AI application must actively keep track of the entire conversation history and securely inject it into all subsequent prompts. For example, if your initial prompt asks for a summary of AI adoption strategies, the model returns a list of key considerations. If you then submit a follow-up user prompt simply asking, "What are the common privacy-related risks?" the model will fail to understand the context if it only receives that single sentence. To solve this, your client application code must programmatically bundle your new question together with the previous prompts and the model's previous responses, creating one massive, comprehensive payload. By passing this entire chronological sequence back to the model, you provide the critical historical context required for the AI to understand that your question about privacy risks is directly related to the earlier topic of enterprise generative AI adoption. In highly advanced architectures, where conversation histories become too large for the model's token limits, the application might utilize specialized techniques to include only heavily summarized versions of the older conversation history, ensuring the model maintains an ongoing context without breaching strict computational token boundaries. Managing this state is a primary responsibility of the AI developer. In your codebase, managing history means maintaining a running array of message dictionaries. Every time the user asks a question, you append an object with the role user. Every time the API responds, you append an object with the role assistant. When the next question is asked, you send the entire array so the model can read the full chronological thread. This diagram illustrates how stateless systems achieve conversational memory. While conversation history provides conversational context, sometimes your AI model needs highly specific, factual data that it was never originally trained on. To add this vital enterprise context, generative AI applications utilize an advanced architectural technique called retrieval augmented generation, commonly referred to as RAG. RAG fundamentally transforms how we build prompts. This approach involves actively retrieving external information, such as internal corporate documents, private emails, or secure database records, and seamlessly using that data to augment the prompt before it is ever sent to the language model. The resulting response generated by the AI is then strictly grounded in the verified information that you provided. Let us look at a practical enterprise example. Suppose an employee submits a prompt asking, "What is the absolute maximum amount I can claim for travel expenses on an international business trip?" If the AI model has no other information, it will respond with a generic, unhelpful answer, likely advising the user to consult their local HR department. A vastly superior solution is to build an expenses assistant application that utilizes RAG. When the user asks the question, your application code first executes a rapid search against the organization's private expenses policy documentation, retrieving the specific paragraphs related to international travel limits. The application then automatically injects that retrieved policy text directly into the system prompt, alongside the user's original question. Now the language model can use the securely retrieved policy information to provide deep factual context, allowing it to generate a highly relevant, mathematically accurate, and completely grounded answer based exclusively on your private corporate data. This technique is an absolute necessity for building reliable AI agents in enterprise environments. Executing RAG in code involves a two-step API process. First, your backend intercepts the user's prompt and queries a vector database, like Azure AI Search, to find semantically matching document chunks. Second, your code concatenates those retrieved text chunks into the system message payload, instructing the language model to answer the user's prompt using strictly the provided context. Here we see the retrieval augmented generation workflow. A user prompt triggers a query to the enterprise vector database. Now that we understand the deep theory behind system prompts, user prompts, conversation history, and RAG architectures, we must explore how to actively configure and test these parameters within Microsoft Foundry. The absolute easiest and most effective way to interact with a deployed model and refine your prompting strategy is to use the model playground located directly within the Foundry portal. The Foundry playground allows developers to rapidly try out different prompts, compare various models side by side, and capture perfectly working settings before they ever write a single line of application code. Within the Playground interface, you can configure several critical model arguments that drastically influence runtime behavior, system performance, and overall financial cost. The first major parameter is temperature. The temperature setting mathematically controls the model's strict balance between creative output and rigid determinism. A low temperature produces highly predictable, factual responses, while a high temperature encourages diverse, creative language. The second critical parameter is max output tokens. This setting explicitly caps the maximum length of the response that the model is allowed to generate, which directly affects your overall token consumption and API throttling behavior. Finally, the playground provides a dedicated text box for your system instructions. This is where you explicitly define the overarching role and strict behavioral guardrails for your model, completely separate from the standard chat interface where you test your dynamic user prompts. The playground serves as a highly visual, interactive bridge between the raw generative AI model and your final enterprise application code. By thoroughly validating your prompt engineering strategies here, you guarantee your agents will perform flawlessly in production. The Foundry Playground features a View Code button that generates the exact Python or QRL payload, reflecting your current UI configurations. This is incredibly useful for developers, as you can tune the temperature slider and edit the system instructions visually, and then instantly copy the perfectly formatted JSON dictionary directly into your application source code. This visual breaks down the Foundry Playground testing loop. Within the UI, developers configure system instructions, adjust the temperature dial, and set max output tokens. In our final section, we will examine how to transition your perfectly engineered prompts from the Microsoft Foundry Playground directly into your production application code. When building a lightweight chat client or a sophisticated AI agent, you will utilize the Foundry Software Development Kit, or SDK, to programmatically connect to your deployed endpoint. Using the OpenAI-compatible Responses API, your Python application code dynamically constructs a structured message payload to send to the server. This payload is typically an array of distinct message objects, where each object is explicitly tagged with a specific role. Your application will first pass a message object tagged with the system role, containing the strict system instructions and behavioral guardrails you formulated in the playground. Immediately following that, your code will append message objects tagged with the user role, containing the dynamic questions or commands submitted by the human interacting with your app. You also programmatically pass your fine-tuned temperature and max_tokens parameters in this exact same API request. By separating the system and user roles in code, the backend language model perfectly understands which text represents the overarching operational rules and which text represents the immediate task to be executed. Mastering this programmatic prompt structure ensures that you can build highly scalable, fiercely secure, and incredibly intelligent AI applications on the Azure cloud. Thank you for joining this expert technical deep dive. If you found this training valuable, please be sure to like this video and subscribe to our channel. Furthermore, to truly accelerate your cloud engineering career, I highly invite you to visit quicktechie.com for our premium certification prep materials, featuring extensive Q&A banks, ebooks, audiobooks, and expert interview guides. In the Python SDK, your API call involves passing a list of dictionaries to the message's parameter. Role, system, content, you are a helpful assistant. Role, user, content, summarize the document. The model parses these distinct roles, applies the system rules globally, and executes the user's specific request securely. Our final diagram illustrates the programmatic code execution flow. The Python client app initializes the OpenAI client and builds a messages array. It strictly assigns the system role object and the user role object.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.